Alrighty, folks. We are in lesson 4.7 notes. Get them out. And we're going to finish the notes today.
Wow. I think we can make this
Yay.
And then work time?
Yes.
Cool.
I'm supposed to be excited for this class.
Okay, we've been talking about inverse trig functions. So, as a refresher, for our domain for inverse trig functions, those are all the like ratios or values for our trig functions, and our output is the angle. Okay, so it's kind of like going backwards. And then we have like those special intervals for what we can answer to make the inverse a function, to get one specific output. Okay, that's what we've been talking about. Okay, we're gonna do a couple applications, only a few, because the next lesson is all like right triangle application problems. So I'm gonna save the majority of those for Monday. So we're just gonna do a couple here. Here we have a 24-foot step ladder is leaning against a building with the top of the ladder at a height of 18 feet. What angle of elevation does the step ladder make with the ground? We better draw a picture. Building, thank you. I got a hype man today. I like this. 24-foot ladder. Thank you. 18 feet above the wall. Angle of elevation is from a line parallel to the ground looking up. That'd be this angle right here. Okay. So right now I know the opposite side of this right triangle. When I talk opposite, I'm talking in regards to this angle that I'm trying to find. I know the opposite side and the hypotenuse. Which trig function relates opposite and hypotenuse? Sine. The sine of that angle would be 18 over 24. You don't really need to reduce that ratio. Let's just let our calculator do the work from there. To solve for that angle, we would take inverse sine. I want to feed in the value, the ratio, feed in the value, get out the angle. Well, we're in a right triangle, so what do you think makes sense? Degrees or radians? Degrees. We want to be in degree mode. Great question. All right, let's check it out. I need to get myself into degrees. Remember, the sine inverse button is right above the sine button. So we feed in the ratio or the sine value, 18/24. It's going to give us out the angle. You should get 48.5903 ... degrees.
Let's go.
Are you kidding? Are you in degree mode?
Nope. I did it wrong too.
Operator error.
Okay, let's write our notes that you need to be in degree mode in right triangle problems.
Wait, I'm in a bad mood. I'm not supposed to like this class.
Listen, just start talking while it's distracting me.
What?
Nothing.
Who's talking? I don't even notice. Were you talking?
I thought Jackson was talking.
Okay, let's just all focus on Precalc, please. I'm like so in my head of like all these things I'm thinking about. I don't even notice. Like, Kaden probably wore his hat in here 10 times. I didn't even notice until today. So that's just
Wait, what?
that's just how I roll.
You told him to take it out?
Yeah.
Yeah,
I was like, have
he's
you
been
done
doing
it?
it for a long
Yeah.
time.
Come on, man.
Okay, so let's put on here.
Oh,
Okay, let's try one more. A soccer ball is placed 10 feet away from the goal, which is 8 feet high. You kick the ball and it hits the crossbar atop the top of the goal. What is the angle of elevation of your kick? Okay, so the goal is 8 feet high. Here's my net. And a soccer ball, I'm not going to try to draw a soccer ball, is 10 feet. That's my net.
Oh.
10 feet away.
I was just waiting for 8 feet.
You kick the ball and it hits the top of the crossbar. What is the angle of elevation of your kick? All right, the only thing a little bit different this problem is This time, for my angle of elevation, I know the opposite and adjacent sides. So which trig function I use this time? Tangent. Nice job, Bailey.
Wow.
You are like really smart.
What over what, folks?
8 over 10.
Opposite over adjacent.
All right, and if I want to solve for the angle, what do I need to do?
Gotta get the second and -1.
Inverse
what is that,
tangent.
arctan?
Or arctan, yep. All right, here's what I got out as the angle in degree mode. Make sure you label this degrees.
My calculator's so good at its job.
Okay, so there's
Now fall down. Yep.
there is an example of one you might need to use inverse solving a right triangle application problem. Okay, the next thing, and pretty much like the last-ish concept we gotta look at, is taking compositions with trig functions. So this is like, if you remember composition like from algebra, like the fog and goth things you said, like taking f of g of x or g of f of x. So it's kind of like we're gonna take the sine of something else and relating it with inverses too. Okay, so you might have something like this. We're going to take the inverse sine of the sine of this angle, or maybe something like this. Take the tangent of the arc cosine or something like that. Okay, now we talked about how obviously inverse sine is the inverse operation of sine. So they kind of like undo each other. Kind of like multiplication and division are inverse operations with each other. 2 times something divided by 2, they undo each other. They're inverse operations. Same idea here, but you have to be careful that you're like, oh yeah, those just cross off, I'm just left with x. That only works if that angle is within that range we talked about, okay? So these do undo each other. If and only if, that's a way to abbreviate if and only if in math, or you can just write if it's within domain and range. Okay. So here's all those intervals. My green marker has not been working today. Here's all those like possible like intervals I was talking about. You know, it has to be within the range of negative pi over 2 to pi over 2 for sine, 0 to pi for cosine, and tangent negative pi over 2 to pi over 2 not included in those. And in that case, yes, they can like, you can just kind of cancel them out. All right, let's look at a couple examples that make more sense. So here, in number 1, we want to take the inverse cosine of the cosine of 3 pi over 5. So what we can do, because of their relationship, instead of evaluating what the cosine of 3 pi over 5 is, and getting a number, and then taking the inverse and getting back to the angle, these essentially undo each other as long as this is within 0 to pi, because that's what my cosine is defined as, right? For my possible outputs for inverse. So as long as this angle right here is within this range, and sometimes it helps to sketch a picture, like especially these ones you probably don't know like as well, like 3, I mean, you guys know where like 11 pi over 6 is, but maybe like negative 4 pi over 11, what quadrant exactly would that be in? So if it helps you to draw a picture, you can. We got to split this into 1, 2, 3, 4, 5. So 3 pi over 5 is in quadrant 2 here, and cosine is 0 to pi, right? So it does fall within that range. So in that case, they just undo each other, and your answer would be 3 pi over 5. Now we could go through the math, you guys. We could go through the math. Let me just quick show you on a calculator, but I got to switch back to radian mode. We could figure out what the cosine of 3 pi over 5 is. Okay, it's this value. And then we could take the inverse of it, and it's going to give us, that's what 3 pi over 5 is. just as a decimal. It's going to give us back that same angle, right? Because you're taking the cosine of it, getting the value, and then you're just doing the opposite to get back to the angle. But again, it only works if that starting angle is within your possible outputs for inverse. Okay, let's try another one. So this one, 11 pi over 6, you're right, this does not fall within our range, right? 11 pi over 6 is down here. There's 6 pi over 6. 12 pi over 6 would be 2 pi. So I'm here, and you're like, ooh, that's not within our range of 0 to pi for inverse cosine. That's not within our range. So what you have to do is find its partner angle that would give us the same cosine value. So this one, this 11 pi over 6 has a reference angle of what? Pi over 6, right? Pi over 6 is a reference angle. All right, in quadrant 4, where 11 pi over 6 is, would cosine be positive or negative?
Positive.
Positive. Cosine. Would cosine be positive or negative in quadrant 4? Positive, right? So what you have to do is you have to find its like partner angle. That cosine has a reference angle pi over 6 and is also positive. Okay? So in my possible output ranges, it would just be right up here in quadrant 1, it would be pi over 6. Now, again, you could go through this and do the cosine of 11 pi over 6. Do you guys know what that is off the top of your head?
No.
Or the cosine of 30 degrees? Yes. It is square root of 3 over 2. And then you could take the inverse of this. So you're asking yourself, what value in between 0 and pi would give me square root of 3 over 2? And you get pi over 6. If that makes more sense to you to kind of like start within your parentheses, because that's how we normally do composition, is kind of like evaluate this first and then take the inverse cosine of it. But it is important to kind of like recognize these relationships with the inverses and like when they can kind of undo each other. Yes, sir.
So are both of those like two different ways to solve that? Or
Yeah, kind of.
Okay.
So if it's easier for you to like look at this and you're like, it's not within my range, let me evaluate what that is and then take the inverse of it. This one ended up being easy because it was one that we kind of just know off the top of our head, right? But a way you can do these every time is just kind of picture where it is, what angle within my interval of possible outputs for inverse would that give me the same value as. I like to do it this way. And I think it's good to conceptually kind of like understand what you're doing, if that makes sense. Okay, other questions so far? We get to do 4 more.
Yes! So excited.
Well, it looks like we
Okay, let's move on to sine.
10.
For inverse sine, what's my possible interval range of angles? Do we include those?
Yes.
Okay. Is 11 pi over 8 within that range?
No.
No, it's not. Let's visualize where 11 pi over 8 is. 1, 2, 3, 4, 5, 6, 7, 8 pi over 8. 11 pi over 8 is here, and sine is in these 2 quadrants. All right, so we got to figure out, first of all, would sine be positive or negative in quadrant 3? Negative. So its partner angle is going to be in quadrant 4, where sine is also negative. This is the partner angle. Then I got to think, what's my reference angle here? What's going to give me the same value?
13.
What's this angle right here? How many pi over 8 am I away?
3 pi over 8.
3 pi over 8. So this right here would be negative 3 pi over 8. And that would be my answer because that falls within this range.
So would negative
So,
would
hold on.
13 pi over 8 work?
No, that's not within this range.
Oh yeah, you're right.
Good question. Hold on, let me explain Carter before you ask the question. I think I lost my train of thought though. I forgot what I was gonna say. Sorry, what'd you ask?
How'd you get the 3 pi over 8?
That's my reference angle.
I know, I just don't.
Like, how did I count it?
Yeah.
So, I don't know what I was gonna say though. What I was gonna say is, like, Bailey, this is a good example of, like, this one we can't, like, just evaluate off the top of our head. Now, like, could we use our calculator? Yeah, but it's not gonna give me that 3 pi over 8, right? Yeah. Okay. 11 pi over 8. So we divide pi into eighths, right? Okay, so half would be 4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 would be 2 pi. So 11 pi over 8 would be 8, 9, 10, 11. Here. So I'm 3 pi over 8 away. That's my reference angle. 1, 2, 3. Reference angle is always to the x-axis. Okay. So what we know with reference angle, we talked about earlier in chapter 4, is that every single angle with that same reference angle I'm going to get the same value. Just like our unit circle. Everyone that has a reference angle of pi over 6 has the same exact sine, cosine value. Just the signs, the positive, negative, differ depending on what quadrant we're in, right? That's what we know about reference angle, okay? That's how we did all those ones where I gave you like 13 pi over 6. You figured out the reference angle. What's just the plain old tangent of pi over 6? It's going to be that same value. Now, depending on what quadrant we're in, it's going to be positive, negative. So here in this case, because sine is negative in quadrant 3, and here's my possible range of values, I have to find that angle that's going to give me the negative version with the reference angle of 3 pi over 8. So if it's negative, it's going to be down here. And now Ashton asked a really good question. He said, well, can I just call that 13 pi over 8? I said, no, because these are my possible output values for the inverse sine. So we have to call that negative 3 pi over 8. Okay, good.
Big brain.
I like these questions. Other questions?
Next one.
Yes, let's try some more. Okay, here I have inverse sine again. So again, I like to jot down my intervals, like right underneath that. Those are my possible outputs for inverse sine. Negative 4 pi over 11. That's obviously going to fall into this. I mean, we can try to divide this into 11s. It's kind of hard when you have an odd number, but it's just going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. But negative, it's going to be somewhere down here. And that falls within my range. And even better, they called this negative 4 pi over 11, right? They didn't call it like, let me think here, 11, 12, 13, 14, 15, 16, 18 pi over 11. So in this case, these essentially just kind of like undo each other because this falls within that range. So it's just negative 4 pi over 11. Does that make sense? So I just tell my students, like, don't get cancel happy. Don't think like, oh, these just cancel. I mean, they are inverse operations. You just have to be conscious of the output intervals for our inverse functions, just like we were practicing with just doing one of them yesterday. All right, let's do a couple more. And don't worry. You're going to get lots of practice in your homework. Okay, tangent inverse. Possible outputs for that. Or anything in between negative pi over 2 and pi over 2, just not including because tangent's undefined there. 4 pi over 5. 1, 2, 3, 4, 5. 4 pi over 5 is over here in quadrant 2. That definitely does not end up in my range of values for tangent. Okay, so I can't just like cancel them out and say 4 pi over 5. That's not a valid range for inverse tangent. It's not a valid output possibility.
Maybe pi over 5?
What'd you say?
Pi over 5?
Close. Is tangent positive or negative in this quadrant?
Negative.
Tangent's negative. So would it be pi over 5?
Negative pi over 5.
It would be negative pi over 5. Exactly. Yep, pi over
Darn.
5. So I got to find a reference angle here. Negative pi over 5. Okay, everybody good with that? These are kind of fun.
No, they're they exist. Not good or bad.
Okay. This next one, inverse tangent again. So I'm going to jot down my possible outputs. And then I look here. Is this angle within this interval?
No.
No. And can I even take the tangent of pi over 2? No, this is just undefined. Because this, we have an asymptote there. Undefined. Okay. Now we're going to kind of go the other way. So these were an example of like composition, but I was always taking the inverse of like the original trig function, and they were the same trig functions, but my inverse was always like my outside function. Now we're going to go the other way of composite, where your inverse is like your inside function, and your outside is the trig function. Okay? So in this case, especially folks, when these are two different trig functions, there's no way those could like cancel each other out, right? Sine inverse is not the inverse of cosine. The inverse is sine. So in this case, we kind of have to work inside first and then work our way outside like we normally do with composition functions. No, we can do this on top. So we got to start within here first. And we have to evaluate this. You guys know what I mean when I say composition functions, right?
Kind of.
No? Okay, it's like this. Like, you don't have to write this down. Just watch me do
Like
some
the
math for a
inverse is
second.
on the inside.
It's kind of like this. That's composition. Where you have like something inside another function. So that's basically what we're doing here. That's why, it's, not that. You got in composition functions with these trig inverses. Okay. So when you do that, with normal, like if you have something like this, and it says, I bet you do this in Algebra 2. How many times am I going to pick up that green marker and remember that it doesn't work?
I feel like you're at 5.
So if you have something like this, f of g of 1,
Whoa.
you start within here and you evaluate what g of 1 is. One,
Put that in.
and then you take f of 1 by plugging that in there. Okay? Remember doing this?
Yep.
Okay, this is kind of same idea here. So
See.
we're going to start within here, and we're going to evaluate what the sine inverse of negative square root of 2 over 2 is, keeping in mind these are my possible output values for inverse sine. So within that range, what angle would give me negative root 2 over 2 for sine? Come on, that's one we should recognize. But negative pi over 4. I don't know if you said anything. Negative pi over 4. Square root of 2 over 2, that one we should recognize that that's pi over 4 because it's the same for sine and cosine. Okay, and since it's negative, it's in quadrant 4. All right, are we ready to go with that? Now I got to take the cosine of negative pi over 4. Cosine of negative pi over 4. So if it helps you to sketch it out, you can. That's down here. I know cosine is square root of 2 over 2. Cosine of pi over 4 is square root of 2 over 2. Hopefully you know that. If not, folks, you can always sketch this thing out. Three, two, one. 3, 2, 1. Okay. Now, is cosine positive or negative in this quadrant? Cosine's positive, so there's your answer. Good. Okay, let's do another one. Arc cosine is the same as inverse cosine. Inverse cosine, my possible range of angles is 0 to pi. So look at my little drawing here. Which angle is square root of 3 over 2 for cosine? Pi over 6. Yep, this one. Pi over 6. So to get negative square root of 3 over 2, in between 0 and pi, 5 pi over 6. Good job, Bailey.
So
5 pi over 6.
How do you get 5 pi over 6?
Okay, let me pull up my unit circle. These are just like the ones in practice yesterday. Let me start over. For inverse cosine, in order to make this a function, we just section off these possible angles because those give us like one unique value for cosine. If you look at the unit circle, cosine is which variable on the unit circle?
X.
X, yep. So if we start here, we have a variable of 1, square root of 3 over 2, square root of 2 over 2, 1 half, 0, negative 1 half, negative square root of 2 over 2, negative square root of 3 over 2, negative 1, and then those just repeat. See, negative, negative, then it repeats. So we have like this unique, specific one, I don't want to say period, but like one cycle here of possible angles that could give us square root of 3 over 2 or 0. Okay, because if I look at my whole unit circle, there's more than one option. Like if I just said, what angle gives me a cosine of 0, and I said anything on here is fair game, we have pi over 2, we have 3 pi over 2, we can call it negative pi over 2, we have a ton of options. So we have to just section it off to these specific values in order to make it a function. That's just how the inverse is defined. Okay, and then like I said yesterday, we can tell by just reflecting these graphs that this doesn't pass the vertical line test. It's like I said, if I said what angle gives me a cosine of 1 half, you're looking here, you're like, a bunch of angles. So when I'm evaluating an inverse function, and these were like all the ones we practiced yesterday, it has to be within that range of numbers. Does that make sense, Jackson? It has to be within 0 to pi, okay? Now, 0 to pi are quadrants 1 and 2. So for cosine, where would cosine be negative? Would that be in quadrant 1? Marker doesn't work. Would that be in quadrant 1 or in quadrant 2?
2.
2. Okay. So we have to figure out what angle in quadrant 2 gives me square root of 3 over 2. And like I said, these ones we either have to have memorized, or I kind of showed you to just memorize quadrant 1 because of the patterns of our unit circle and because of reference angles, that if you know these, those values hold true for all 4 quadrants and any angle really. 3, 2, 1, 3, 2, 1. Okay, you told me cosine's x. So this angle right here has an x value square root of 3 over 2, right? Okay. Which angle is that?
30 degrees.
Okay, what's 30 degrees in radians?
Pi over 6.
Pi over 6. So every pi over 6 angle in each quadrant that has that same reference angle of pi over 6, I'm going to have a cosine value of square root of 3 over 2, right? These all have reference angles of pi over 6, or 30 degrees, meaning 30 degrees away from the x-axis. They're always going to be the same value. And that would work if we had pi over 17, something really, really small, okay? That's always going to happen, that they have the same values as long as they have the same reference angles. All right, so we already decided it has to be in quadrant 2. And we know it has to have a reference angle of pi over 6. So which angle, my brain's kind of tweaking out today. Which angle in quadrant 2 has a reference angle of pi over 6? And that would be 5 pi over 6. If you're not comfortable with that math, split it up into 6. Split it up into 6, and you're like, okay, I know it's this angle in quadrant 1, so to get negative, what's this? And you can count 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. Does 5 pi over 6 fall within that range? Yes, so we're good. Okay, let's keep going. I guess my advice to you is if this doesn't make sense to you, like this thinking of just memorizing quadrant 1s, then you're just going to have to memorize them all. You just have to know them. Sorry. That's true for you. Okay. Now that we've evaluated inverse cosine, now we can take the tangent of this. Again, I know tangent is y over x. I can go through the math here of doing.
Hey, Margaret.
Thank you. Of doing y over x, or you just have this memorized. It's square root of 3 over 3.
We're at like 8.
Okay, or again, folks, I've showed you this a lot of times. Do this and do the math to get there. Okay, whatever you need to do. Is tangent positive or negative in quadrant 2?
Negative.
Negative, so it's negative. You want me to show you the math of how you get square root of 3 over 3?
No.
Are you sure? I will.
No, I didn't know. That's okay.
Oh, silly you. I mean, we can see that right here too. Obviously, from our unit circle, we went through and did those before. Okay. It just takes practice, guys. Don't worry. It's just I can't emphasize enough like how well you need to like know your unit circle. And like I mentioned, like when you get to like calculus, I won't go through and like explain this. I just expect you to know, oh yeah, tangent 5 over 6 is square root of 3 over 3. Okay. So practice that now. All right, let's try another one. With inside here. Why is it doing that? It's like highlighting a bunch of stuff. No, it's not me.
Just
Okay.
punch it. I'm sure I can do something.
Inside first. Inverse tangent of 1. For inverse tangent, what are my possible range of angles? Okay, what's my possible range of angles?
Yeah, that's it.
Thank you, Megan. Yep, not including those, right? All right. Based upon just the value itself, between these two quadrants, what quadrant is my angle going to be in? 1. Tangent is positive in 1, negative in 4. And that's why we sectioned it off there, so we have unique values for each inverse. There's only going to be one possible angle that gives me a positive 1. Tangent is y over x. So which angle, when I do y over x, would give me 1? Pi over 4, right? Pi over 4. Y over x, anything over itself. So that right there is pi over 4. Does pi over 4 fall within that range? Yes, we're good. Okay. Now we have to evaluate the cosecant of pi over 4. So these are ones like you guys did, like when I made you take like those no calculator parts on the quizzes, the tests, the semester exam. Like you know how to do these ones. Cosecant of pi over 4. You can do it 2 ways. You can either reciprocal.
Markers.
You can either reciprocal sign or you can have this memorized. Anyone have this one memorized? It's just root 2. Yep. But okay, sine would be this reciprocal. Rationalize that 2 root 2 over 2. Square root of 2. Since we're in quadrant 1, everything is positive. I love quadrant 1. Okay.
Do we have another trick after this?
Chapter 5 is more trig.
Let's go.
That's pretty much what Precalc is. It's like all trig.
I don't like trig.
You don't?
What are those problems that like take a really, really long time?
That's chapter 5. Like the
Oh.
ones you have to verify the identities.
I remember watching Haley do that last year.
Yep.
Oh my god, what are you doing?
That's coming up next, folks. Probably not next week, but the week after.
Will you want me to cry?
Yes.
'Cause it'll probably happen.
Okay. Now, these next ones. I'm just going to erase my work up here so I have more room.
Okay.
Oh, I don't want to erase that. I start within, and I want to evaluate the arc cosine or the inverse cosine of 2/3, and you're like, wait a minute. That's not on my unit circle. I don't know what that is.
I agree.
Nope, not calculator. If that's the case, you've actually done this before too. Let me phrase it this way. This is what this is telling you. The cosine of some angle is 2 over 3. Right? That's what it's telling us. Do you guys remember how you would solve a problem like this? And this is how I would phrase it. Evaluate all of the other 6 trig identities if you know this ratio. And then you'd set up, okay, well I know cosine is 2/3, secant is 3 over 2. Do you remember how you'd figure out the other ones? Draw a right triangle. Exactly. Yep. Draw a right triangle. I like to put it on the coordinate plane because sometimes there can be negative ones. So for cosine, where would cosine be positive in my possible range of 0 to pi? What quadrant? 1. So let's go ahead and draw a right triangle in quadrant 1. And we know the cosine of this angle, which is adjacent, over hypotenuse, is 2 over 3.
2 squared. B squared. B squared.
Yes, this side ends up being the square root of 5, Pythag. So, what you can do to kind of like show your work here, basically what I was saying there is the inverse cosine is some angle. So now they just want us to find the tangent of that angle. You don't actually even have to figure out what the angle is. Okay? It's some angle. They just want me to take the tangent of it. So tangent, I would do opposite over adjacent. That would be my answer. If you want to, you could like figure out what the angle is, but then when you go to take the tangent of it, you're going to use the exact values anyway. So it wouldn't really make much sense to actually solve the angle. Draw your picture, label what you know, and then you just have to take the tangent of whatever that angle ends up being. Okay, let's try another one. Ooh, we only have a few minutes left, don't we? Okay, no problem. Start within here. This is telling us that the cosine of some angle is 2 root 5 over 5. Is that an exact value we have memorized from our unit circle? No. So I'm going to have to draw another right triangle. And again, this one's cosine. So it's in quadrant 1 again. I know the adjacent side is 2 root 5. And the hypotenuse is 5. Do some Pythag. You'll get this side to be the square root of 5. So again, we really don't need to solve for that angle. That just helps me set up my right triangle. So the inverse is some angle, and now we just need to take the cosecant of that angle. Cosecant is a reciprocal of sine. Sine is opposite over hypotenuse, so this one is hypotenuse over opposite. Rationalize, of course. Square root of 5, yep. Okay, so the reason why we can't use our calculator for this is because I'm getting exact values, right? That's the goal here. All right, better finish up this last one. This one's a little different. Inverse sine of negative 3 fifths. Okay, so here's my possible intervals for sine. So what quadrant would that be in if I have a negative value for sine? 4. Yep, between 4 and 1, it would be in quadrant 4. The sine of some angle, which that makes sense that this would be like negative 3 over hypotenuse. Pythagorean triple. Anybody know what that other side would be? 4. Nice. Okay, so again, we don't need to even figure out what that angle is. We just need to take the cosine of it. Adjacent over hypotenuse. Does it make sense that we got a positive answer for cosine in quadrant 4? Yes. Yeah, that makes sense. Okay? All right, we'll stop there. You should be able to do most of your homework. There's like a couple ones that are like some problems from calculus that are fun. They're not too bad, but practice these guys. Practice your unit circle. Now, like, I'll make you guys a quiz there. Just practice getting to know some of these others.